Okay. So here we go. What we're talking about today, we went through weathering. Actually, what was the last section we looked? Mechanical and chemical weathering. So the two different types of weathering. Today we're going through erosion and deposition. So these are the effects of weathering. So we often bump them all together, weathering and erosion. Know that erosion is a completely separate thing. Weathering is the actual breaking down of the rocks, making them smaller, turning rocks into sand. Erosion is the movement of that stuff. Yeah. Once I break it down smaller, I can move it around into different places. And deposition is going to be the end point of that. Whenever it stops moving, wherever it lands and falls permanently, that's going to be deposition. I guess it technically doesn't have to be permanent, but wherever it stops moving from erosion, that's what we're going to call deposition. So we're going to go through this a little bit. Know that we're just touching lightly on this. This is a huge branch of science. Looking at erosion and deposition, most oil and gas work is all this stuff. People who work at oil and gas companies are very, very good at sedimentary processes like erosion and deposition. This is what they live on. This is where they make their paychecks. And so this is a huge branch of geologic science. And most of the highest paid geologists do this kind of work, erosion and deposition kind of work. If you can go in to a rock package and tell them what type of erosion and deposition was happening, or better yet, on a map, point to a place where deposition was happening, you can make a decent amount of money working in the oil and gas industry.
How much money do you think they...
Well, look up salaries for oil and gas industry. Not right now. We're talking about the section. If you're interested in oil and gas, it's only a Google search away.
This kid doesn't brain work.
Don't do it right now, this second. But look it up on your own time, or come in during activity period. You got a lot of questions. Never see you in here during activity period. I'm just sitting here twiddling my thumbs. Yeah, well, you know what's nourishment? Intellect for the brain. Yeah, it's just information. It's nourishment. Keeps you alive. Okay, so erosion and deposition. We'll see. Did they have much to go through over here? Okay, they're showing Niagara Falls here. Niagara Falls is a huge, huge waterfall. It's basically, instead of just one single waterfall, it's this whole curved area of waterfall.
I mean, it can't be that big. It fits on your board screen.
Yeah, okay. Let's hold the cracks to the end. But there is a lot of erosion that's happening here because there's a lot of water moving. And so these kind of things happen all the time. I actually went through a different PowerPoint today with my dual credit class, and we saw an actual pretty good picture of some homes that had some bad erosion problems. So you can see here real quick, 1997, I don't know when these people bought this house, but 1997, the people who are living here, you got a decent sized front yard, right on the beach, nice property. Erosion starts to happen because of storms. In 2004, notice the front yard's gone. Literally, you step out of your front door and your feet are in beach sand. Might seem nice. It's not nice. Your house is in danger here because the foundation that it's built on is slowly being eaten away. Less than a month later, literally less than a month later, same month, September 8th, 2004, September 29th, 2004, the front yard is now gone. The front part of the house is collapsed. Whatever value you had in this house is now gone. It's worth $0. No one's going to pay anything for it. Hope you had insurance. House next door is next on the list. It hasn't collapsed yet, but there's literally no front yard left. There's only foundation. And so erosion is a real big deal. And knowing where weathering and erosion is going to happen can save you a lot of money, or you can make an entire career out of it trying to help other people save money.
A lot of houses that are on beaches and everything, aren't they built on stilts?
That is a new thing that we're doing. Yes, it is expensive to build a house on stilts. Your beach houses that are elevated. Yeah, but yes, that is the thing that we're starting to do. It's something that a lot of parts of the world have had trouble with. Is when someone owns land, especially in the United States, it's very difficult and kind of looked down upon for the city to come in and tell them what to do. And so we have a lot of instances in the United States with people making bad decisions and the government just being like, yeah, sure, go ahead, build that cheap house on the beach. And then when it gets knocked down, we all have to pay for it as taxpayers because they get emergency relief. And they use that money to build another cheap house right on the beach that's going to get knocked down in the next hurricane. And so the best bet is to go in and tell people, yeah, if you want to build on the beach, that's fine. But it's got to be one of the stilt houses. It has to be built to a certain height. It has to be able to withstand certain winds. And if you're not, then, well, I'm sorry, you can't afford to live on the beach. Go find somewhere else to live. And essentially, we didn't talk about it in this class. Oklahoma did the same thing. I don't know how long ago, roughly a decade ago. They passed a law. They were tired of seeing Oklahomans die in tornadoes. And they passed a law. Every new house built has to have an underground tornado shelter, period. You can't build a house. You can't do reconstruction on your old house without adding a tornado shelter. It has to be done. If you don't want to pay for a tornado shelter with your house, that's fine. Go live in a different state. You can't live in Oklahoma now. And that's basically what they said. And a lot of people were upset about it, but it's saving lives every time they have a tornado. The majority of people have somewhere safe to go and ride out the storm. Yeah.
All right, so say there's a tornado, right? And you get inside the little shelter thing.
Yeah.
What if something like blocks off like the door?
So you gotta be blocking off the door is not a big deal because eventually somebody's gonna come by and clear off that rubble or hear you yelling for help and you'll be able to get out. A real big deal is, can you still get fresh air? Can you breathe? And do you have power to pump water out? If there's a leak and your cellar fills up with water, you could drown. And so that was actually one of the tragedies of the Moore tornado that I lived through in Oklahoma. A part of a school collapsed, and the school had an underground tornado shelter, but the power was knocked out. And so the underground tornado shelter flooded while the children were down there seeking rescue, and some of them passed away. And so it's like, you're doing these things to try to protect people and save them, and it doesn't always work out in the way that you intended. And that's why you got to have safeguards for this stuff, and you got to check it frequently.
I don't know why they shouldn't allow them to build them near like where water lines are. Then
it wasn't about water lines; it was about the rain from the storm. And there's pumps in there to pump the water out, just like you have in a basement or boats have them. You don't want water in your boat, you got a pump to pump it out. If it's a big enough boat, not just like a little John boat. But yeah. But if the power's out, then the pump doesn't work, and now you have problems. And so there's probably a little bit of extra thought that has to go into that. But the point is, instead of reacting to this stuff, always the best method is to prevent it by keeping people from doing things that put themselves in danger. And so if we're talking about weathering and erosion, you keep people from building right on the beach. You can own beach property, but your house has to be a little farther back. Or if it's going to be right on the beach, it's got to be on stilts. It has to be built in a certain way. Maybe you have to have hurricane insurance. I got to have some protections here. So I know if something happens, I'm not going to be footing the bill for your mansion that's right on the beach. You're going to be paying for it yourself. So, did you have a question? Are you good for now?
How does the water even get in it?
Oh, in a tornado shelter, you got to have air to breathe. So if there's a hole for air to come in and out of, if it's raining hard enough and the hole's not designed properly, water can come in and out of it.
The hole that you go down into, you think they build it up above your house?
Yeah. Well, I'm sure they thought they did everything right. I doubt the person building it was like, yeah, this is not a very good job, but the kids will never use it. It was probably just a freak accident that happened, and they didn't foresee the things happening that did. I don't know all the details about it. It was a terrible tornado. I mean, it was about as bad as it can get. And so I imagine that whatever situation led to that flooding down there, they just didn't even see that as a possibility. Didn't
We should just kill the tornado.
Didn't make that there. All right, listen. Hey, shut up. Let's focus on weathering and erosion. So what they're worried about here, this is actually a big deal. We spend a lot of money on this every single year. It's tough because no one's afraid of dying from this. Like, unless you're in some freak landslide where you're standing on the edge of a cliff or underneath a cliff and all the rocks fall on you. Weathering erosion doesn't really like endanger your life. It's not something we need to be afraid of. What it does do is cost us lots and lots of money. In Texas, we have real bad problems. It's not really necessarily weathering erosion, but a bunch of houses have foundation problems. And every single year, homeowners spend thousands and thousands and thousands of dollars just trying to keep their house level and keep it from getting cracks and having weird problems. And so you factor stuff like that in, erosion off the side of highways, beaches, all sorts of different things. And this becomes a very, very expensive problem that we actually waste a lot of money on.
Yeah,
And so,
my house is doing that.
yeah, in Texas, it's a huge deal. Everybody's house has
It's
problems
like
with it.
Starting to do like that, I guess our hill. So like my whole room, everything leans to the left. So like to watch TV straight, or like
Yeah, and your doors don't close right.
No.
You can get leaks in your pipes. It's a big, big problem. So outside of oil and gas and outside of studying this stuff to try to help ourselves and not build in the wrong way, we do also study this for science. So what we're looking at here in our main sections, we want to look at the relationship between weathering and erosion. So the weathering breaks down the sediments. The erosion moves it to a different area.
Whoa.
And ultimately, when it gets there, you're going to have deposition. And deposition is actually a really important part. How your sediments get stopped, where they stop at, and how they build up is going to determine what type of rocks you have. So this is the difference between like a sandstone that's not going to give you much other than maybe like sandpaper or some other like building material, or getting like a nice shale that you can drill oil and gas out of, or some sort of package that has drinkable water. There's a lot of different things, and knowing how these things are formed, knowing what environment they form in, gives us a better chance of drilling in the right area, because you can't see anything underneath. So in order to do these expensive wells and find this good material, we kind of have to have an idea of where it's going to be before we start to look. Yeah.
So we were taught wrong the whole time.
Wrong about what?
Weathering and erosion. Because I thought erosion breaks it down and weathering like makes it shallow.
Yeah, no, it's the opposite. It's the opposite. Which is not a big deal. Now you're on board. We got you straightened out.
mine.
We're good to go. We're good to go. Maybe it's just a miscommunication.
Weather was the thing that moved.
I wouldn't jump to the conclusion that you were taught wrong. Just maybe there's a little
I think
miscommunication.
he listened wrong.
Well, I'm not trying to throw out accusations. It's just a miscommunication. That falls on both sides. Because maybe he did hear wrong or he listened wrong, but it's upon the teacher to make sure that the students get the right information. You shouldn't let someone walk out of your class thinking up is down and down is up. You got to correct that stuff. So now what we're talking about is methods of sediment transport. How are your sediments getting moved around? The vast majority of the time, this is going to be water. Water is your main carrier of sediments. Sometimes it's wind. Wind does blow some sediments around. The thing about wind blows all sorts of different directions. So it might blow it this way one day, but the next day it might blow it right back the same way. In general, water only goes one direction. What's the direction water goes? Downhill. It's going to go downhill. It's going to go to your lakes. It's going to go to your oceans. And so water is the major carrier of sediments. It's where they get deposited. It's how they get moved around. The last one is going to be gravity. So we have wind, water, and gravity. Gravity is mostly going to be landslides. Landslides are going to pull your sediment from a high place to a low place. There's not going to be much side-to-side movement. It's generally just falling down, but still it is moving. And so that is a part of erosion. Gravity is pulling on stuff, always pulling it down. Let's see. Let's keep going. Sediment size and deposition. Here's the thing. Y'all seen footage of creeks and rivers and stuff flooding, right?
Yes.
The idea is the faster the water is moving, the bigger the stuff it can pick up. If I try to drive my truck through like a small little creek, I don't have any worry about drowning. If I try to drive my truck over a bridge that has like a full flooded creek flowing through it, there's a really good chance that creek could pick up my entire truck and move it down the creek. We've all seen it happen. Every single year, someone gets stuck trying to cross a bridge that they shouldn't cross because water's over it. So the idea is the faster the water moves and the more water you have, the bigger the stuff it can pick up. Personal example, when you go to, I call it Wet and Wild, but what's it called now? The water park, Hurricane Harbor. You're in the lazy river, and your parents are like, hey, we're getting out. And you're already past the stairs. Like, how hard is it to move against the lazy river and go back upriver? It's really hard. And that just that's a little amount of water in a tiny creek, not even moving very fast. If you look up video of like the Mississippi flooding, like a huge river with a lot of water, it picks up entire houses. It picks up entire bridges and washes the bridges downstream. And so the more water you have, the faster it moves, the bigger stuff you can pick up. And so the idea is, right when it's raining and the streams are the fullest and the water's flowing the fastest, my rivers and streams can pick up big things, big rocks, pieces of sand, sediment, dirt, sticks, logs, trees. As soon as it stops raining and the rivers calm down a little bit and they slow down, all the big stuff falls out first. All the big stuff starts to fall out first. And so what you'll see when you dig down into like a stream or a creek bed, if I can find my marker, I got a couple over here. I can do it over here. What you see if you dig down into like a stream or a creek bed is you will see these alternating layers, starting with big stuff. The big stuff happens like right during the rain, during when the flood is the biggest. And as soon as the water calms down, the big stuff falls down to the bottom. Then over the next week or so, we're still not getting any of the rain. The creeks are drying up and drying up and drying up. And the water's going from this nice like muddy brown color and starting to get clearer and clearer and clearer. What's happening now, my middle-sized stuff is starting to fall out and it's landing on top of the big stuff. So I have like a layer of middle-sized stuff. And then as it dries up and the water's not moving at all, and even the tiny little dirty dust particles are too heavy for the water that's not moving, it's all going to settle down. I'm going to have like the tiny little grains that fall out as the river dries up. There's no more water. All the dirt just falls down, and there you go.
Will the little ones get mixed up with the medium-sized ones?
Not really, because everything is just kind of setting. They're sitting down. You'll have a little bit of mixing sometimes, and they could like fall in between cracks that might be in there. But in general, you will be able to see the layers. And then the next time the river floods, what happens is, and you can see this sometimes out in fields. It doesn't have to be in the river. You take really dry land and dump a bunch of water on it. It doesn't always soak in right away. You actually get like a mud layer that forms at the top and will hold all the water up at the top. And so when the next rain comes through, this top layer doesn't get washed out. You start to deposit the next set of big sediments and rocks right on top. And so as you dig through these creek beds, you see these layers, big, medium, small, big, medium, small, big, medium, small, over and over again. Every season, every year, it builds up these layers and kind of stores them in the ground. And so you find that afterwards, there may not even be a creek or a river there, but if you see sediments like that, you know there was some sort of stream, you know there was some sort of creek, and that might lead you to find the thing that you're looking for. So sediment size and deposition is all about how fast the water's moving and when it does that. When do I get rain? When do my creeks rise? How much energy can they carry forward? Are they going to drop the big stuff like boulders and cobbles first? And then they go through the smaller stuff all the way down to your really fine sand, clay, and silts. Let's see. Next page. It goes to the next page. And last page, what are you talking about? Beach erosion. Beach erosion is a really big deal. I almost wish we'd go through the other PowerPoint. But basically, what we kind of talked about in the dual credit class, what is it like? I wish I had the numbers. Something like 50% of Americans live in a county that has beach access. So like a coastal county. So like Ellis County has no beach, right? So we're not one of that group. But if you take up all the counties that have beach and all the counties that don't have beach, 50% of Americans live in a county that borders the ocean. Not even a lake, but the ocean. So most of the country lives right by the ocean. The rest of us are spread few and far between in the middle part of the country. And so what that means is when we talk about beaches losing erosion, we talk about cliffs being undercut. Here in Texas, we might be like, that's not that big a deal. Like, how bad could it be? The truth is, while it's not necessarily super dangerous, again, it costs us a lot of money as a country. We spend millions and billions of dollars every year fixing this stuff.
What about in Louisiana? They don't have counties.
They would have used precincts or something like that. Yeah, they would have used some county adjacent parishes. There you go, not precincts, but they do have like voter precincts and stuff. But yeah, parishes. I love Louisiana. Like they're so different. They're like, well, we don't want to use your system. We got our own system.
I'm gonna ask you a question after this.
Okay. But basically, like to show you an example here, let's look at some beach erosion. So here's an opposite example. This is a beach in Miami in 1970, and you can see that the beach is almost gone. Because of all the building they've done here, there's no new sediments coming to the beach, and every wave that washes in takes sediments away from the beach. Here you can look. I mean, you got maybe 10, 15 feet of beach from your paved hotel patio to the actual water. That's not very good. No one wants to set up their beach chair with their back to like a brick wall and the waves right next to you. That's not the day on the beach that we imagine. And so they spent a lot of money and did a lot of work. And by 10 years later in the 1980s, you have a big, large beach set up here. Now, to be fair, these are rich hotels. They probably just trucked in a bunch of sand, like literally brought in dump truck after dump truck of sand and dumped it on the beach. That being said, you still have to do a lot of work to keep the ocean from just washing that sand back away. And so there are things that you can do, but we spend a lot of money doing that. And the same thing kind of goes for that house that I showed you earlier. These people bought this house, and look at the house 7 years before this happened. You got all this front yard. You got a beach here. They probably had never crossed their mind that the ocean would cut the land out from underneath their house and their house would literally collapse. They're not on a cliff. They're not on like a really high elevation. It just took the sand right out from underneath their grass, and the front part of their house had nothing left to stand
When
on.
they saw the beach or whatever, this grass washing, why want to be like, hey, yo, bro, come bring me.
So, but that's the thing is, once this starts to happen, you can do stuff. And they actually talked about it in this PowerPoint for dual credit. Once you make that decision, though, you're basically fighting nature. You can put a wall there. You can bring in some new sand. Every second of every day, the waves are coming, and they never stop. And so whatever you're going to do might last a while. You're going to have to pay to do it again and again and again and again as long as you live there. And so, yeah, they could have fought this, and they might have. This is 7 years, so they might have done a couple things in between here or there. But at a certain point, the water's going to take it back, and there's not a lot you can do about it. Unless you just have unlimited funds and you can constantly fix it like a hotel or something. But for a homeowner, at some point in time, before this picture, you either need to sell the house or figure out what you're going to do to get it further back away from the beach, because it's not going to work. It's not in this PowerPoint, but in another one, they had pictures. They literally moved a White House, or not a White House, a lighthouse. The lighthouse that shows the ships. It was too close. The ocean was about to literally knock it down into the ocean, and so they devised this crazy way and picked it up and moved it further away from the ocean and set it back down with these giant machines. Like, I'm sure it cost millions and millions of dollars. But for a homeowner, your ability to do that is basically zero. But that's at some point here, you have to come to the realization that either I'm going to dump a bunch of money into this house, or I need to get rid of it. I need to sell it or just abandon it or something.
A bunch of people
'cause it ain't gonna work.
knowledge of all this, they just think, oh, that house looks nice, I'm gonna buy it. You know what I mean?
Well, it's a little bit of both. Yeah, either you're not thinking about it or you're not listening to the people that tell you. They're like, hey, this is a risky purchase. You maybe shouldn't do this. Yeah, it'll be all right.
On the lighthouse thing, wouldn't it be cheaper just to build a new one?
Well, in that case, yes, but then you're talking about like a historical thing.
Yeah,
So it's probably like several hundred years old.
The one down and then put it back up.
Yeah, and the thing is, with modern technology, unless you're in a really weird place, we don't even need lighthouses anymore. All the ships have depth finders, and you have accurate maps of the seafloor. You don't need like a lighthouse to physically point at the rocks. It's more like a historical thing. The same way people in Waxahachie fix up the gingerbread houses. You can build a new house for cheaper, and then have nicer stuff, but they want the old, like 100-year-old gingerbread house. That's what they're trying to do.
See the rocks at night when they're coming in. Like, is
Yeah.
there like an actual like movie or something about a ship that the lighthouse went out and it
I think so, yeah. There's a movie about it. But yeah, the lighthouse would just shine like a literal giant flashlight onto the rocks where they came out of the ocean so the ships wouldn't hit the rocks. And that's like the whole job, is I just point at the rocks in the nighttime.
One that did just put a light on the ships. And like,
Yeah, you think, just give me some headlights for my ship and then I can see the rocks coming. But ships are hard to steer. Once you see it, it's usually too late. You kind of got to know about it beforehand.
And then it's too late when they see the rocks. So they just
So look, let's go over some things real quick. Let's go through these things that they're going to say they're doing for beach retainment. So they're trying to keep their beach there. Shoreline hardening. So this is literally putting in like seawalls. I forget the other term. Jetties, groins. They're basically large brick walls to kind of keep the sand in a certain place or keep the water out. So when they mean shoreline hardening, they mean literally like I'm putting in cement or rock features to keep the shore where it is. Sand retention structures, those are going to be your groins, your jetties. Basically, as the ocean naturally washes my sand away, I can put little things in its path to kind of trap that sand and keep it in certain parts of the beaches. The bad thing is it kind of makes the beaches look a little less bad because now I have a bunch of brick walls all on my beaches. But the beach at least has sand and I'm doing something a little bit good. Now with these, a lot of times they backfire because the people that build them don't understand the science. They just throw it in there and turns out it should have been in a different location or they should have used a different method. Beach nourishment, like I said, that's what they literally just chuck in sand. If you go to a hotel somewhere and there's a nice like white looking beach that feels great on your feet, that sand didn't come from the beach. They brought it in from somewhere else. It was cleaned up and freshened up and they bring it in so your feet are nice and you're like, I'll come back to this hotel. If you go to a natural beach, you'll know it right away. There's usually shells and corals and sharp stuff, and you usually have to wear your flip-flops. If it's not muddy and you don't have to wear your flip-flops, you're probably at a beach where they brought in some sand. No, let's not disparage any beaches because they're fake. Yeah, they're fake and they brought in sand. A beach is still a beach, and I don't care where the sand came from. If it feels nice on my feet and it's hot, we're good to go. I'm not some like beach snob where my sand has to be organic sand, like grown by I don't know, organic cows or something.
they make fake cows?
They make fake cows, they make fake sand, and I don't want none of that. No. Yeah. Bringing in sand is not a problem. That's something that we just have to do or we wouldn't have a lot of beaches.
It's when they try to lie to us.
Have you seen those commercials about the people that are starting to make meat out of vegetables or whatever?
Oh yeah, that's the. Hold on, we'll talk about that in a second. Soft stabilization is like adding plants and trees along your shoreline. This is okay, but in general, people who we do this at lakes and all sorts of natural areas. This isn't used as often as it should in beaches and neighborhoods because if I buy beachfront property, I don't want a bunch of plants and trees blocking my view. And so in general, we're less accepting to the soft stabilization than other things. But this is like nature's way of building beaches and keeping your land intact. Is more trees, more plants, roots to hold everything in place. So, river erosion, they talk about Niagara Falls a little bit. I did talk about river erosion, and so the more water you have and the faster it moves, the more stuff it can pick up and erode. For Niagara Falls, we saw the picture earlier. It's huge. Niagara Falls is a really large waterfall that passes a lot of water through it every day. And when it falls over the cliffs, it's gaining a lot of speed. And so when it hits the bottom, it is pulling up sediment and doing all sorts of stuff. And that, has anybody ever watched the gold digging shows with the gold miners?
Yes.
They talk about they talk about the glory hole, right?
Yeah.
And that's at the bottom of a waterfall, right?
Yeah.
And so that's what they're saying is when the waterfall. Why don't I have any markers? Where's all my markers? They're over here.
There's a green one right there.
Oh, my bad. When the waterfall plunges down, I'll do it over here. When the waterfall plunges down, basically you have your ground level, and the waterfall comes down here and hits and splashes, right? But it's going to cause erosion, and so what the gold miners are looking for, the waterfall will dig like this deep hole in the bottom of the river. The water level's like way up here. You don't really see it, but underneath the waterfall is this deep hole. Gold is really heavy, which is why miners would use pans, because they can swirl the pan. All the dirt and stuff would just fly out of the pan, but the gold stays sitting in the bottom because it's nice and heavy. The same thing happens with the waterfalls. If I have gold flowing through my river, it goes down the waterfall, ends up piling up down here at the bottom of this glory hole, this plunge pool for the waterfall, and that's what they're trying to find. Because if they can find that, they know there'll be a lot of gold down there in a really confined place. They're not going to have to do a whole bunch of digging. And so that's that kind of same thing. The faster the water's moving, the more water there is, the more erosion happens. And that's why that little like hole gets dug underneath there. Okay, so real quick, how much time do we have left?
10 minutes.
Only 10 minutes. This is an easy assignment. If you want to go ahead and do it, you can do it. It will be open tomorrow because the seniors are coming back. But the assignment, which I thought I had open in another tab. Hold on, let me see. Yeah, it's here. It asks you two things. Look, define erosion. I'm sure there's a definition for erosion in the reading. Define deposition. I'm sure there's a definition for that in the reading. To be fair, you could probably define either one of them just from what you know. And then the last thing, compare the roles of erosion and deposition through actions of wind, water, ice, gravity, and constantly reshaping the Earth's surface. So just kind of go through what I said, like how wind and water, ice a little bit, but not so much. Wind and water are going to be the main things that transport your sediments. The faster the wind or the water is moving, the more sediments and the bigger sediments they can transfer. And then when they stop moving, when your water stops flowing or your wind stops blowing, that's where you get your deposition. All your sediments fall down, they land on the ground, and they're going to stay there. So if you have any questions about this, let me know, and I'll help you answer it. Make sure you hit submit at the end. And that will be open tomorrow for the seniors.
You didn't assign the reading.
Oh, let me assign that.